as I discussed in the next previous segment, we talked about two fluid interactions, or a better sentence would be when acoustic passes from one medium to the other, what happens. And then now in this segment onwards, we will be talking about this case where you have rho 1 C1 here, rho 2 C2 here, and rho 3 C3 here. Okay, and now you have pressure wave coming from this side. Then we have to study, we want to study what happens then. Thing is, as usual, P reflection will be there, and what we will do, we will put, so this is region 1, this is 2, and this is 3. Is that the thing which I have taken? 1, 2, 3, yeah, okay. Then we can put a subscript here to denote that they are in region 1, because incident and reflected things will be there in other things also, other domains. Now this wave will come, some part will be reflected, but some part will be transmitted, and that thing we will call them, say here, Pi2. Whatever got transmitted across will be like incident wave that side. But then on this segment again it sees a mismatch of impedance, so some part will be reflected, so PR2, right, and obviously the remaining portion will go, and here we will say PT transmitted, because we will assume that beyond this it's infinity and no wave is coming back from that side. Okay, so these are the 5 waves which now exist. And again, like in the previous case, you should keep in mind, you are talking in terms of time domain. If you think in, we are talking in frequency domain, sorry. If you think in time domain, things are very complex. You have to think that, okay, wave will come, some part will be reflected back, some part will go there, and this will be reflected back, but then once this wave comes, it will also be reflected back some amount, but something will be transmitted. This wave also is no special, so something will be transmitted based on the transmission coefficient there. Similarly, this one, when it is going, part is coming back but part is reflecting. So a lot of things are happening in these interfaces. Now if you start thinking about those things, means then it will be very difficult to imagine what's happening. But if you actually conduct a transient analysis, it will move like that. Okay, numerically, suppose this problem you want to solve numerically, suppose using finite element method or something, finite difference method, whatever. Then if you are using a transient analysis, actually the thing which I am talking about now will happen. You can see them happening there. But then if you wait for quite a bit of time, then everything will be stabilized. And one more thing, these are sinusoid waves. You are not applying any random waves, these are sinusoids. So that's why your say Pi will be like A1 e raised to j omega t minus k1x, right, and this real. Okay, but then this P reflected one, yeah, will be B1 e raised to j. You can write all the other things on your own, right? So this will be the reflected wave, and here once you are expressing in this form, you are saying two things. One is you are applying a sinusoidal pressure in a wave which is incident in coming into the thing, and things have stabilized. That means the steady state has reached. Okay, after that only you are talking about everything. All those things have happened and all the energy balances are happening now. Then so then your Pi2 will be say A2. Now A2 will be complex, e raised to j omega t minus k2x here. So note here k1, and this is complex, points to be noted. Then omega is same everywhere because pizzas cannot get stacked. And anything else here, k2. And then P reflected 2 will be V2 e raised to j omega t plus k2x. Then P transmitted will be this, I'll delete, I'm feeling bad about this. Yeah, PT will be A3, right, e raised to j omega t minus k3 x minus L, where L is the distance between this. Okay, so this is very important. Okay, so these are the 5 pressure waves which you need to use to solve further, and we will stop here for this segment because this just tells you that what are the pressure fields which will exist, but there are and then can you now tell me what are the unknowns here? I mean, everything is unknown except this, so that means we are sending A1 and we have to figure out what B1 will be, what A2 will be. Now everyone will have a different phase now with respect to A1, and we don't know what they are. So every such component, so this is 1, 2, 3 and 4, so these 4 things will have both amplitudes and their phases are unknowns, which we need to solve by applying boundary condition at these 2 places properly. And again in this case, because we are using fluids, so the pressure on this side will be same as pressure on that side, particle velocity continuity and particle velocity continuity. So we will use them and derive these other, basically the reflection coefficient and transmission coefficients, and we will see in the next segment. See you then.